Designing Green Data Centers with LEED. In this video, we're going to be talking about the state of data centers and the massive amounts of energy they consume, and also what designers are doing today to tackle this problem.
We're also going to design our own data center based on LEED, Leadership in Energy and Environmental Design, a rating system that is recognized as the International Mark of Excellence for green building in 150 countries.
It's no secret that data centers, the massive but bland, unremarkable looking buildings housing massive amounts of information, consume a huge amount of energy. The demand for data center capacity in the US grew tremendously over the last 5 years. US data centers consumed about 70 billion kilowatt hours of electricity in 2014, representing 2% of the country's total energy consumption. That's equivalent to the amount consumed by about 6.4 million average American homes.
Efficiency improvements have played an enormous role in taming the growth rate of the data center industry's energy consumption. In fact, without these improvements, staying at the efficiency levels of 2010, data centers would have consumed close to 40 billion kilowatt hour more than what they did in 2014 to do the same amount of work.
Researchers expect total US data center energy consumption to grow by 4% between now and 2020, reaching about 73 billion kilowatt hours. Google is on the frontier of greening this industry. Google has been carbon neutral since 2007, and in 2017, they're expecting to reach 100% renewable energy in all their operations, including their data centers.
Leadership in Energy and Environmental Design, or LEED, is a rating system devised by the United States Green Building Council, or USGBC, to evaluate the environmental performance of a building and encourage market transformations towards sustainable design.
Buildings can earn a certified silver, gold, or platinum rating based on the number of points they earn. One example of LEED is improved cooling efficiency. Using chilled water storage systems, for instance, has the potential to transfer up to 10,400 kilowatt hours of electricity consumption from peak to off-peak hours daily.
Another example is reduced energy consumption. In fact, monitoring power usage in real time and leveraging analytics during operations helps to allocate power judiciously. Distributing power at higher voltages reduces power loss, and eliminating energy-draining transformers helps to convert power to the appropriate voltage and reduce the generation of heat. The overall aim is to maintain low power usage effectiveness, or PUE, which is a measure of the energy used by comparison to the IT load.
Points in the LEED rating system can also be earned for innovative practices such as light bulbs with reduced mercury content, or even simple changes such as providing all employees with reusable coffee mugs to reduce waste.
LEED has 4 categories: sustainable sites, water efficiency, energy and atmosphere, as well as materials and resources.
Now we're going to study an example data center. Our data center here consumes 500 kilowatt hours of power, and the average energy cost is 12 cents per kilowatt hour, giving a total energy cost per year of $525,600. Using LEED, we will address the high cost of this data center as well as its environmental impact.
In the sustainable site category, we'll meet the prerequisites by avoiding pollution during construction, since there can be a lot of it, especially when it's rain. Pollution on construction sites can be reduced by controlling SAW, or soil erosion, airborne dust generation, and waterway sedimentation.
Another LEED element in the sustainable site category is light pollution reduction. This credit is worth 1 point. In this project, we will reduce the amount of uplighting used for exterior lighting, avoid pollution of light into adjoining sites, and control light levels outside the building to meet LEED standards.
Another LEED element in the sustainable site category is protect or restore habitat. This credit is worth 1 to 2 points. For this project, we will preserve and protect around 60% of the greenfield or undeveloped area on the project site. In addition, we will provide financial support to an organization accredited by the Land Trust Alliance, giving us an extra credit.
Finally, in this category, there will be a vegetative green roof area installed on 72% of the total roof, and a vertical green wall covered with vegetation and is irrigated with harvested rainwater.
In terms of water efficiency, the facility will use a free cooling system that employs water-side economization. In this system, cool outside air is incorporated into a heat exchanger to supply cold water for the data center's cooling system.
The facility also uses reverse osmosis water treatment to reduce sediment buildup in its cooling towers, which is expected to save 5 million liters of water per year.
In the energy category, we plan on building a 1 megawatt solar power facility to support operations of the data center. As well, a fuel cell powered by biogas that can generate up to 500 kilowatts of power will be installed beside the data center. This biogas generator will produce electricity from domestic waste.
Running this facility on 100% renewable energy, we receive the maximum points for this category, which is 7, and excess electricity is sold to the grid for a profit.
In the material category of the lead system, to gain points, rather than building a new data center from scratch, we plan on using an existing building by retaining 97% of the walls, floor, and roof of an unutilized factory space. We'll also source 50% of construction materials regionally and build with 30% recycled materials.
In order to address climate change, save money, and create more sustainable buildings, we need to adopt the LEED standards, and data centers can be a major driver in this movement.
We hope you learned something today and that you're now motivated to work toward a cleaner and brighter future.
Thanks for listening.